Welcome to the second example video for section 2.4. So in this problem, it's going to be very similar to the last example that we just did, except we're given a little bit of different information about our function. So we need to use a different form of quadratic functions in order to find our equation. So here we see we've got here's our situation. It says a meteorologist creates a parabola. So parabola, when you see that, you know that it's quadratic. So a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in Celsius. So you see here that you're starting, so x equals 0, that's right now, and then anything after that is the hours after midnight. So x would be your starting point. X is midnight. And as x increases, that's hours after midnight. So we're going to go from 0 to 24 because it's predicting the temperature tomorrow, so in the next 24 hours. Okay, so that's why our curve goes from x equals 0 to x equals 24. It's a 24-hour temperature prediction. So x is the hours after midnight, and y is the temperature. And you see the temperature changes. It starts out here. We know our first point, 0, 9.6. That means at midnight, the temperature is 9.6 degrees. And then as it gets later in the morning, it's going down, it drops, and then it starts to rise again. Okay, so if you look at this, we know a few points on here. So we're given a few points, the starting point, and then we've got these 2 points where our parabola goes through the x-axis. So these are our x-intercepts. So for this problem, we're going to have to use our intercept form, which if you remember, it's y equals, and then we've got a times the quantity of x minus p times x minus q, where p and q are the x-intercepts here. So just like last problem, when you use the vertex and 1 point to find your a value to get your equation, you're going to do the same thing here. Although this time you're going to use your x-intercepts, which are p and q, so 4 and 24, and then you're going to plug in your point, 0 and 9.6 for x and y. And then we're going to solve and we'll get our a value to get our equation. So if we go through, let's go through step by step. You see we're going to use intercept form, so we're going to solve for a. We go ahead and write down our intercept form here, and then we plug in, if we plug in 4 and 24 for p and q, and then for x, we plug in 0, because that's our x coordinate. So see, everywhere you have x, in both these places we plug in 0, and for y we plug in 9.6. So now we're down to, we've got one equation with just one unknown. So just like last time, we go ahead and simplify this. So we get -4 times -24. So we get 9.6 equals 96a, and then we get a equals 0.1. So by using a and our p and q values, now we can go ahead and plug those in, and we have our equation right here. You'll see the equation is f of x equals 0.1 times x minus 4 times x minus 24. So that's our equation. That's the answer to the first part, right, our function. Now to figure out the coldest temperature, when it says coldest, what that means right here is the minimum point on your graph. And remember, minimum point is the vertex. So what we learned about last time, if you remember from last section, when we talked about our intercept form, we learned that our vertex and our axis of symmetry is exactly halfway in between our x-intercepts. So halfway between 4 and 24, we'll find our axis of symmetry. So in order to do that, in order to find it, we need to go ahead and we just take both of our intercepts and find the average between them, find the middle. So we do 4 plus 24 divided by 2, and we get 14. So that's not our final answer though, because we want to know the coldest temperature, which is the y value. So we know that our coldest temperature occurs 14 hours after midnight. So to figure out what the actual temperature is, we just plug 14 into our equation, and we go ahead and get our value. So substitute 14, we go ahead and simplify, and we get that negative 10 degrees is our coldest temperature. Now, to solve the second part, so for part B, here we're going to hear a different term. What is the average rate of change in temperature over the interval in which the temperature is decreasing and increasing, and compare? So here, rate of change. Okay, this right here, another way to think of rate of change is the slope. Okay, slope is another way you can think of that. Now, parabolas don't have slopes. Okay, only straight lines have slopes. So parabolas are curved, so this has a slope that's constantly changing. But we want to know the average rate of change. So basically, what we want to do is let's look at our parabola right here. Okay, we want to know what the average rate of change is over the intervals in which it's decreasing and increasing. So what that means is we're going to look at both sides of our parabola. Okay, we're going to look to the left of the vertex and the right of the vertex. Now, every parabola has one side that's increasing and one side that's decreasing. Okay, no matter what your parabola looks like, one half is always increasing and the other half is always decreasing. It doesn't matter, each parabola is a little different. So if we look right here, decreasing, we're talking about the y values. So as you go from left to right, you'll notice that here our y values are decreasing. Okay, we're going down. We start at 10, we go to 0, and then down to negative 10. On the right-hand side, as we go from left to right, they're increasing. We're going from negative 10 up to 0. So the side in which we're decreasing is to the left of our vertex, and the side to which we're increasing is on the right of our vertex. Okay? Now, that might be different. If your parabola looked like this, we would be increasing on the left and decreasing on the right. So each parabola is going to look a little different. So for our situation, when we want to find the average rate of change in temperature, we look at the intervals. So the interval for which we're decreasing goes from x equals 0 to x equals 14. Okay, that's our interval for which we're decreasing, we're subtracting. The interval for which we're increasing, we're getting bigger, is from 14 to 24. So what we want to do is we want to use these intervals right here and find what the slope is between the 2 points at the end of our intervals. Okay, so what that means is we're going to go ahead and we're going to take the points that make up the left and right hand side of our intervals. So from between 0 and 14, what we're going to do is take the slope. F of 14 just means the y value, and f of 0. So we're taking the y value at 14 minus the y value at 0 divided by 14 minus 0. Okay, what that means is, again, if you look up, we've got our vertex, which is at 14, negative 10, and our initial point, which is at 0 and 9.6. We're just finding the slope between those 2 points. So remember, our slope formula is y2 minus y1 over x2 minus x1. Okay, x2 minus x1. So what we're doing, again, is we're taking the 2 points that are at the end of our intervals and we're finding the slope between those 2 points. In this case, we get that our average rate of change is negative 1.4. Now, that makes sense because that's on our side that we're decreasing. We're decreasing between 0 and 14, so our average rate of change is negative 1.4. In order to find the average rate of change in the interval that we're increasing, we just take our 2 points that are at 14 and 24. So again, we're going to use 14 and negative 10 and 24 and 0, and we're going to find the slope between those 2 points. So let's go ahead and plug those in. So we get 0 minus negative 10, that's y2 minus y1, over 24 minus 14. So we get 10 over 10, which is 1. And again, that's positive, which makes sense because we're increasing. So our average rate of change over our decreasing interval is negative 1.4, and our average rate of change over our increasing interval is 1. Okay, so really, rate of change is just finding the slope between 2 points. And when you're finding it over an interval, you use the points that are at the ends of your intervals. Okay? Now this last part, compare the average rate of change. So this is what it looks like here. We just found the slope between the 2 points for our decreasing interval and the 2 points for our increasing interval. And when we compare them, because 1.4 is greater than 1, the absolute value, what that shows us is that the average rate at which it's decreasing is faster or is greater than the average rate at which it's increasing. So that's all compare means. Is what do you notice? Is one faster than the other? So because this is a greater number, it means that during the interval which it's decreasing, it's going down at a greater rate than the rate at which it's increasing. Okay, so that's how you solve that problem. Again, you're using, it's the same type of method, except instead of using vertex form like we used in the first problem, you're using your intercept form, which uses your intercepts and then 1 point to find your A value. And then as far as looking at the intervals for which you're decreasing and increasing, you just have to look at your graph and find the ends of the intervals and then just find the slopes between those points. So what I want you guys to do are answer questions 3 and 4. So here for number 3, what if the y-intercept was 4.8? How does it change your answers to A and B? So what that means is instead of 9.6, what if it was 4.8? Everything else stayed the same, but your y-intercept was 4.8. I want to know how that would change your equation right here. So how would your equation change, and what would the coldest temperature be? So write your new equation and the coldest temperature, and I want to know what the rate of change is for the intervals in which it's decreasing and increasing again. So I basically want you to redo this problem, except you're going to have a y-intercept of 0 and 4.8 instead of 0 and 9.6. For the second one, I want you to, here's some information. You've got a point 2 and 5, and x-intercepts negative 2 and 4. I want you to write the equation in intercept form of the parabola that passes through those points. Go ahead, enter those now, and remember to label them separate, 3 and 4, so I can tell the answers apart. Go ahead and enter those now.